The question is, in the silicon BJT circuit shown below, assume that the emitter area of the transistor Q1 is half that of transistor Q2. The value of current I0 is approximately, the silicon BJT circuit is as shown. The options are, first option 0.5 milliamperes, second option 2 milliamperes, third option 9.3 milliamperes, fourth option 15 milliamperes. Now we will see the solution to this question. The circuit is redrawn and the currents are as marked. In the question, it is given that the emitter area of transistor Q1 is half of that of transistor Q2. So we can write IE1 as IE2 by 2 and IB1 as IB2 by 2. Now we will calculate the voltage VB. VB, as we can see from the diagram, we can simply get it as minus 10 minus of minus 0.7, which is the VB voltage, and hence we get it as minus 9.3 volts. Since the voltage at this node is same as the voltage at this node, we have I1 as I1 equal to 0 minus of minus 9.3 by the resistor value, which is 9.3 kilo ohms. We get this as 9.3 by 9.3 kilo ohms. This is 1 milliampere. Since the current flowing across this branch is 1 milliamperes and beta value is very much high for this transistor, we have assumed that IC1 is approximately IE1. And since this is I1 and the current here is IE1, we can simply get this as I1 minus IE1, which is 1 minus IE1. Now we will apply KCL at this node. Applying KCL, we get it as 1 minus IE1 is equal to IB1 plus IB2. Now we will express this in terms of IB2 only. You know that IE is nothing but IB plus IC, which comes as IB plus beta IB because IC is beta IB, which comes as beta plus 1 into IB. Substituting IE1 as beta plus 1 into IB1, we get this as IB1 plus IB2. Now we know that IB1 is IB2 by 2. So expressing IB1 as IB2 by 2, we get the equation as shown. Now we will take IB2 as common. From this we can get it as 1 equal to beta plus 2 by 2 plus 1 whole into IB2. Now the value of beta which we have considered here is nothing but that of the transistor Q1, so it is 700. So this comes as 700 plus 2 by 2 plus 1 into IB2, which comes as 351 plus 1 into IB2. So the value of IB2 is 1 by 352. Now in the question it is asked to find the value of I0. Now I0 is beta 2 times of IB2, which we can simply see as 715 into 1 by 352, which is approximately 2 milliamperes, which is the final answer. So the correct option is option B.